You did not say that, or I did not hear you, or you maybe not have
I
actually
did.
talked.
I told you. Remember in calculus class, I was like, "Oh, we use it over textbook in my computer,"
Oh,
and
yeah, yeah.
I didn't have time to like or the money to just build one. So hopefully I can just upgrade this one whenever I need to.
Send me the information on it, and I'll tell you.
A desktop. Why would I buy a laptop? I already have a laptop.
You
You
mean the
have
one that
to,
you
The
really
laptop
like to work yesterday?
is busted.
yeah, send
Straight
me
busted.
the link to the one that you bought, Dante, and I'll tell you how bad you did.
How much you spend on it?
Hold on.
All right,
It was
so
with tax 750.
That's not bad.
what was the angle yesterday? 20 degrees, right?
It was 20.
Only thing I
US
need to
was
fix about it is
0.15.
Are you going live on
maybe a
Twitch
little bit
again?
more storage.
Yeah, it should be popping up now. No, just like I said, send me the link after the class, and I'll help you out and tell you how bad you did. Bruh, pre-Brit's never the way to
Well, the
go.
thing is, building a PC, it would probably take like it,
It's really
oh
easy.
wait, can I hear myself in the?
And you mute shit. That's why you mute Twitch.
Oh, okay. I couldn't tell. I didn't have this problem yesterday.
Oh, yeah, mute Twitch. All right. So the question was, what is the acceleration of the blocks, and what did somebody get?
Was it both blocks? I thought it was just
Well,
the
they're
80 kilogram block.
they're connected, so they're going to have the same acceleration.
Oh,
So what did we get?
I did mine
I need my
Twitch this week.
paper.
I genuinely did not know how to do it.
Wait, are
I
you
was
on
10 good
Twitch?
for sure.
Yeah,
Yeah,
he just went live on Twitch.
Oh, you just went live.
It says
Okay.
that he's
bruh.
offline, but
Refresh the page.
Yeah.
You can't just sit on the
I'm
page. You have to
looking.
refresh it.
Oh,
Okay. So what do you
I'm
mean you
like,
had no idea? It's the exact same problem I did yesterday, but now there's friction. I literally set you up step by step for the problem.
I don't know how to do friction. I don't know how to include it. I'm
It's a
stupid.
force. That's all it is. So
Not.
let's think about this because it should have been this. It's exactly the same as what we did
Isn't it
yesterday.
just
100%.
is normal force times the coefficient?
That's for friction to calculate it. Yeah. All right. So what was the first step we did yesterday? What was the first step we did yesterday?
Made
Draw a
a
free
free
body
body diagram.
diagram.
I mean, yeah,
So what's
Free
going to
body
be the
diagram.
first step we do today?
draw a free body diagram.
free body
So
diagram.
free body diagram. So you have block. Remember, this was block one. This was block two. So for one, for two, two is the easier one because well, nothing's changed on two. It's just force of gravity and force of tension. Block one, for the most part, will stay the same. We have the force of gravity down. We have the force of tension up. We have the normal force perpendicular, just like yesterday. That all stays the same with one addition of friction. The question is, which way does friction go? Well, remember, what do we know about friction? What does it do?
It goes the opposite way of our acceleration.
No. Careful.
It's parallel to the direction of motion, the opposite direction.
There you go. So the only thing you had wrong there, Hunter, was you used acceleration. Friction opposes motion, not
Yeah.
acceleration. You gotta be careful. So this is why when we did part one, I set you up 100% for this problem. If there was no friction, which way would the 80 kilogram, because that's one friction on, which way would it move? We figured this out yesterday. Which way does the 80 kilogram block move?
Oh, it moves to the right or like upright.
So it would move up the plane. So which way is friction going to be?
The down.
Down in the plane. If we had not done part one yesterday, that would have made figuring this out a lot harder. What you have to look at is if friction wasn't there, which way would the block be moving? Well, fortunately, like I said, we did that yesterday with part one. We figured out the blocks would be moving, the 80 kilogram block itself would be moving up the plane. So we already know that. So friction has to be down the plane. Okay? That's the
Gotcha.
only difference. Now everything else that follows will be 100% exactly the same. We'll sum our forces, we'll solve for things, etc., etc. So again, we'll push the blocks together, but we now have this added force of friction. So when you go to put them together, you level them out. Nothing on block 2 changes. So that's going to be FG2 to the right. But on block 1, we now have FGX to the left and the force of friction to the left. Does everybody understand that part? I'm going to assume by silence that means yes.
Can you repeat what you said?
I cut out for a minute because I accidentally closed the browser.
Are you
So,
using a browser?
Well, I'll download the app later. I just
Wow.
set up the computer.
it's all good. So the box 2 is the easy one. That one didn't change. So the force, if I level them out, the only thing causing it to move being the force of gravity will change from being down as I flatten it out to being to the right. And on the 80 kilogram block, we have the force of gravity pulling it down the plane and friction, not necessarily pulling it down, but that's the direction of friction. So it's kind of that idea there. So the 50 still has the FG2 to the right. The 80 now has FGX and the force of friction pointing to the left as I level them out. Chris, turn your sensitivity up on your mic, please. Turn your sensitivity up on your mic or use push to talk. So at this point, we push them together just like we did yesterday. Again, 130, we have FG2. Over here, we have FGX plus F, force of friction. Hello, Father. Okay, same thing, then we sum our forces up. So sum of the forces is now equal to, which way do you guys want to be positive? Left or right? It's your choice.
Right.
Okay, so we get FG2 minus FGX minus, G1. I forgot my ones. G1X minus force of friction. And the sum of the forces equals sum of the forces equals
Sorry.
sum of the forces
I'm still
equals.
trying to get the Twitch stream up.
We should still be able to answer that question. Sum of the forces equals.
Sorry about that.
MA.
Sum of the forces always equals MA. First line is always going to be everything with variables. We're not going to put anything in just yet. Okay. So a couple of things we already know. We know the force of gravity 2. We know the force of gravity 1x because we calculated these yesterday. We know the mass. The only two things we don't know are the force of friction and the acceleration. So we ask ourselves, how do we calculate force of friction?
No.
I don't know. There's a formula for it. You were supposed to write this on your formula page.
Just a second. I have to look at it.
Your force of friction will be less than or equal to mu s Fn. That is for static friction. And your force of kinetic friction will be equal to mu k Fn.
Wait, O'Donnell, I have a question.
Has an answer.
How do you know which forces to use for each box?
Because of the free body diagram.
Yeah, but like, why don't you use the other two forces for the baby box?
Which two forces are you talking about?
The normal force and the other force.
Does normal force or tension, do either of those cause the motion when I push these boxes together? Well, normal force would be pointing upwards. That doesn't cause any motion because it's only being counteracted by the pull down. So normal force doesn't cause box 1 to move. The tension force is by us pushing these boxes together. Remember that we call that an internal force? So we're getting rid of that because it's acting on both boxes. So by squishing them together, we've internalized the friction force, or tension force, sorry. So the tension force is all contained inside of our box now. So that's how we got rid of it.
Okay, that makes sense.
So that's why we don't use those. We only use the ones that cause motion. In this case, the gravity and the friction.
Why is the static friction like less than whatever you wrote?
Remember, we talked about this. If I push on a box and it doesn't move, I've got some frictional force. If I push harder and it still doesn't move, then I've increased the frictional force. So remember, that's an inequality. It's not the static friction can be anything from 0 all the way up to that maximum value of static friction.
Okay.
Hunter,
What is that?
Yes.
Is someone
either
watching something?
turn the anime off or
Oh.
push to talk, bruh.
My bad. I have pushed to. I have pushed to mute. I shouldn't do that.
It's pretty embarrassing.
I didn't
Why
realize
are
I
you
was
watching something
out
right
loud.
now?
Because I don't
What
know,
are you watching?
they're weird. Some
It's,
anime.
You know, it's probably a lot harder to describe.
Yeah, nobody cares. We don't need to talk about it right now. Okay.
Just say it.
So the question is, with this force of friction, we have to figure out, is it static or is it kinetic? Because if it's static, our answer's done. We have no acceleration. If it's kinetic, we need to continue on to find the acceleration. So what we want to find out is the maximum force of friction. That is equal to mu s Fn. Okay, so we're given our mu s is 0.15. Does anybody remember how to find Fn on an inclined plane?
Yeah, I think. No.
Okay. Remember the force down the plane, the gravity from yesterday was mg sine theta is down.
Yeah.
So
Okay,
the
so we
one
need the y
into is the mg cosine. So it'll be 80 times 10 cosine of 20. Whatever that ends up being. And why is somebody listening to the volume on the stream?
Mine's on mute.
Pull up my calculator and get that answer for us. Alright, so as we're trying to find our maximum force of friction, if our maximum force of friction, if we can beat it, we're moving. If we're not beating our maximum force of friction, we're done, we stop, and we say, okay, that's it, we're done. It is not moving. Cosine of 20. I get that value to be 112.76, so 112.8.
Wait, how do you know that's not even not moving?
That's what we're getting ready to look at right now. This is the maximum force of friction, that 112.8 number I just found. If we don't have enough forces to beat 112.8, we're not moving. So what that means is when I look at this up here, the FG2 minus the FGX1, we found this number yesterday. I forget what it was. Does anybody remember what that number was?
What was? Sorry.
The FG2 minus FGX. I think we did that yesterday.
Wait, where'd you get the 112.8?
The calculation's right there, the US times Fn.
It's one. Oh. I don't know. I can do it though.
So it looks like it was 500. Oops.
Minus 273.6.
All right, so that's going to be 226. So if I do these right here, this becomes 226.4 minus the force of friction equals the mass, which is 130 in our case, times A. Okay, that 226 number is these two right here. So if I add and subtract those two, I get 226. That comes from yesterday. We did that calculation already. Okay, we don't need music. So since we have that number, we got to ask ourselves, this 226, am I beating the friction value of 112.8?
Why did I write this twice?
Uh-oh.
Calm down.
Okay, again, am I beating that 112.8 number?
Wait,
I can't see.
no. Wait, yeah. What?
Is 226.4 bigger than
Yes.
112.8?
Yeah.
So am I beating the friction?
That was in front of it.
I'm sorry, my thing isn't catching up with what you're saying.
Wait,
Have you tried? Are you watching on your phone or on your?
I'm watching on my phone
Are you on the
because
Wi-Fi?
I don't have a micro. Because sorry, I don't have a microphone to talk to you on Discord for my computer. So
Right, are
connected to
you?
my.
That's fine. But are you? So you're watching. Which one are you
I'm
watching the
watching
stream on?
Twitch and Discord on my phone at the same time.
Do you have a computer?
Yeah.
Have you tried watching the Discord or watching the Twitch on your computer?
No.
That may be something
Try
you
it.
might want to
That's what
try
I
to do
do.
to see if you have a better connection on your computer and the speed's a little better. Because
Should
you
be
being that far behind is really bad. Yes, wired
I'd say.
connections are the best. But even if she's using a laptop, like sometimes the connection will just be better. You may also want to try. I don't know how much data you have on your phone. You may want to try watching on your data, but that could use a lot of your data. So that's all dependent upon how much data you have and things like that.
Okay.
Because yeah, you being like 30 seconds back is not good for you.
All
It's
right.
also really strange.
I don't know why it does that. Because my internet's not bad.
Yeah, I don't know. It's weird. But anyway, so yes, we do beat this frictional value of 112 because if we look at the rest of the forces, there's a net force of 226. 226 is obviously bigger than 112. So what am I going to use for my force of friction in my equation then?
The
Use the kinetic coefficient.
I have to use kinetic friction. Don't fall into the trap of placing this 112 number here for friction. If I beat my maximum force of friction, it's no longer static friction, which is what we used in that equation. We have to jump to kinetic friction. So when I go to use that number in there, I have to switch over to the kinetic value. So I'll calculate that like over here. So our kinetic friction is equal to 0.1 times 80 times 10 times cosine of 20. Let's see what that is. So 0.1 times 80 times 10 cosine of 20. I get that to be 75.18.
what you wrote.
So that is the value that we'll plug in for that force of friction. So we don't need this maximum force of friction. It actually doesn't help us after we've established that we're not going to use it. So we do 226.4 minus 75.18 equals 130. Okay.
Wait, I have another question.
Go ahead.
Where'd you get the 220? Is it 226?
0.4.
200. Yeah. Where'd you get that from?
F of G2 minus F of G1.
It's from yesterday.
Yeah, we already calculated those numbers yesterday, so I'm not going to recalculate them because they don't change.
Oh, okay, that makes sense.
Yeah, but notice how it's right below the equation. The only thing I changed was there's no more FG2 minus FG1x. I just did that subtraction for those values. Because we've already calculated them, I don't need to calculate them again. And then solve for acceleration, and I get 1.16. Meters per second squared.
I have a question.
Oop, I have an answer.
Okay, so like when we're doing like the mock exams for AICE or whatever, what if you accidentally forget like a sign or not the sign, the units or whatever?
Then you would lose points.
Cool. I was just making sure.
Yeah.
This
so,
would still be meters divided by seconds squared, right?
Yes. And what you'll notice is, remember from before, you may not remember, but a lot of on the free response, they have the units there for you already.
Okay.
So not always, but sometimes, especially on the free response, they do. Obviously, on multiple choice, they like to confuse you on some questions with units by having wrong ones there and stuff like that and different things. But mostly on the free response, they had the units there so that you had to put it into the units that they wanted.
Okay. And have you figured out about the experiment thing?
Mm-mm.
Cool. Oh my God, who is that?
I'll have to wait and see what they put on Tuesday, what they put out information-wise.
Okay.
Okay, any other questions from this question?
No.
Damien said his internet was like popping in and out, so that's why it's not you.
Likely story.
You know, I never thought about it. Oh, look when what I figured out. I added a key. Now I have a toggle mute button instead of just a push to talk.
Or you could just use push to talk. You only talk when you push that button.
I feel like I'm way more involved if I don't have a button.
As long as you don't have random people running in your room screaming,
Sure,
I don't really care.
The only
What
person who runs in my room right now is my
you know that
neighbor.
little.
She's a bunny. What's up, Dante?
Good question, Dante.
Guess not actually.
Okay.
Oh,
Anybody else? Any questions on this question that we did? Anything I did anywhere?
no.
I couldn't hear all of it because everyone's voice except for Hunter's is like fading in and out for me.
That's very strange.
That's
I
a you
can't hear
problem.
anything right now.
That's super strange. Try closing out Discord and coming back in.
Might refresh it and see if that doesn't work.
Can you hear us now, Dante? I don't know. We'll figure it out. All right. So, any questions?
No, but no.
Okay, that is honestly forces in a nutshell.
Wait,
Draw
can
your
we
free
do
buy
one more
diagrams, sum them
example?
up.
I
Like,
think it's better now.
I hated every single second of that.
Well, it hates you
is
too,
it
Alyssa.
now?
Yes,
Yeah, I know.
Kenna.
Can you do one of those like
Word is-
trapezoid problems where there's like 3 different weights and then there's one on the top and then there's 2 on the side?
You mean like something on a table?
No, I can send you a picture if that'll help you look at it better.
Go for it.
What do you want me to send it on?
Just Discord's fine.
Okay. It's sending.
It's being very slow.
Yeah. Yeah, I took it. It's just sending. It's taking a minute.
Mm-hmm. We'll see.
Whatever. I don't know if it's like the exact same thing. Like, is it just the same way we do this one, or if it's a little different? Well, obviously it's gonna be a little different, but I don't know like how much.
Oh, so it's
I
like two
forgot
things
how to
sitting on a
do that.
table, except for it's not not laying on. Okay, I got you.
Yeah.
Okay. Okay. You want friction or no
What's it
friction?
again?
With friction.
No problem. With friction? Okay. Somebody pick a mass for the top box.
5 kilograms.
You said 5 kilograms? Okay.
85.
All I hear is 5 still.
85.
Oh, 85.
35. But
35?
cut out.
I said 85.
Okay, so 35 kilograms. Okay, so pick a mass for the right box.
45. No, 50.
Too late. 45 it is. Left box. Alyssa, go.
60.
71 kilograms.
Thank you, Alyssa.
I couldn't hear you say Alyssa. So.
You might want to get your headset checked. You're fine. Let's do Hunter, left angle. Hunter.
Yeah.
Left angle.
What?
Left
Oh,
angle.
60.
Jesus. Okay.
God.
Chris, right angle.
61.
Chris, right angle.
He's muted.
Hold on a second. So right angle. Hold on, I got to refresh this video. My fault.
Just pick a number for the right angle, buddy.
Oh, let's see. I'll say 45.
Okay.
Nice.
Okay. We want friction, you said, right, Kenna?
Yeah. What is that status
That's
thing?
Chris's mic. You can go back to muting yourself,
Yeah, yeah. I need to get a mic.
buddy. So we'll just keep the same numbers as before because I don't know how this is going to turn out, so I don't want to make them too weird.
Okay. It was.
Don't you need 3 diagrams for this one?
You will have 3 free body diagrams. That is correct.
Yes.
Dude, there's a fly near me and it's really annoying.
You can just eat it.
That's not a good shot whatsoever. Is that supposed to be a .1?
Yeah, it's .1.
Okay. I really can't ever see your dots.
Okay, so you guys have fun now. I'm gonna just sit here and laugh at you while you can't do the problem.
Oh, you're so funny.
All
It
right.
just feels like we're back in class, baby.
I know, right? Want this to
I'm
be
saying nothing like class. I'm tired all the time.
want this to be a normal experience, you know, just you struggling and me laughing at you.
Tension, the tension force is always the same way the rope or string is, right?
Correct.
Okay.
Yes, you should be doing your free body diagrams, and then I will advise you after that. So you should be working on those now.
Quick question.
Yeah.
How do you know which way is supposed to be the friction without doing like what we did yesterday?
That's what you'll have to figure out.
Okay.
Hold on, let me go get my fucking notebook.
That's what makes us have. If you set the problem on the outset with friction, that's what makes this quite difficult. Although when looking at it, it should be pretty easy to tell which way friction is going to be. You do want to double check everything, but it should be a relatively easy calculation to figure out.
Yeah.
Well, I mean, look at the picture. Which way is it going to try to move?
A second. Okay, I have a quick question after that, like before I answer the other one. Because 35 is being pulled in 2 directions, would you have tension going both directions?
Yes.
GG. Do you number those? I don't
Yes.
think you do.
Are they different
Why?
tensions?
Yes.
How do you know
I
they're
have no
different
clue.
tensions?
I don't know. I'm dumb. I'm just guessing here.
We talked about this yesterday. Because they are different ropes, they will have different tensions in them. They could have the same, possibly, don't get me wrong, but because they are different
Okay.
ropes, they will have different tensions.
Oh. Okay.
So we're doing a free body diagram.
You should be working all 3 free body diagrams.
Make sure for every block,
Mm-hmm.
right? Okay.
do we go ahead and draw the diagram where it's like flat?
After you get your 3 done, then that you can start moving on to that. Yes, I'm giving you guys a couple minutes, and then I'll do the free body diagrams. What'll end up happening because of how much time's left in class, I'll be able to start it for you, and then your homework's going to be to finish it.
What's
What
that
time
like?
does this class
What's that
end?
noise?
That's my fan, because I'm hot.
No, it's
The
like it
Purge.
sounded like yeah, it sounded like
The
the purge.
Purge.
It's a humming noise because it's my air conditioner. It's a little portable air conditioner, basically. So it cools the air and blows it on you.
One of those little spritz fans that like you put
You're
water
so extra, Mr. O'Donnell.
Dude, you see me sweating in class when class is like 60 degrees. You think I can afford to keep my house temperature like that? No. And then when you close
We can
doors
try.
and have lights and stuff on, it gets hot.
Oh, whatever.
on. So it starts smelling like gamer.
Okay.
Dante didn't laugh at my joke.
Because it was stupid.
Damn.
I'm now lost on how to do this. That's so great. No, I'm not. Maybe. Would there be 3 different types of gravity?
Yes, because each
Because
box has its
all of
own.
them are different. Huh?
Yeah, each box will have its own.
Okay.
Are we supposed to figure out like in what direction the box are going right now, or do we like wait to do friction?
You need to figure out which way friction is. So you need to figure out if there were no friction, which way would the boxes travel? Yeah, so this is not a relatively simple problem because there's a lot of frictions going on. It might end up moving. I don't know though because there's a lot of friction.
Hey, Mr. Donald. So, so the line between the 60 kilogram block and the 35 kilogram block, yeah, that's just one. Like that's the same value both ways, right?
Yes.
Okay, that's fine.
Yeah, each string has its own tension, but a different string will have a different tension.
There's only 2 strings, right?
Right, but I'm saying like if you have more than one string,
Okay.
so one string
Yeah.
will have the same tension all the way throughout. But as soon as you move to a different string, you have a different tension value possible. Now, like I said, it could end up being they could be the same. It's not very likely to happen, but it is something that you could run across.
Okay. I was just making sure because I only put 2 down. So I was like confused. But okay. Um, oh yeah, Donna, what time does this class end?
115.
Oh. Okay.
Wait, have we consistently been getting out at 1:15?
115. Yes.
Oh,
I haven't
15.
been paying
Oh,
attention.
yeah, I thought you said 50. Like, wait, what?
That's what I say. I haven't
Wait,
been in
how do we
class,
know
so I
which
don't really
way?
pay attention to the time. So maybe we could get out 1:15, but it seems
How
like
do
Well, I
we
mean,
know which way it's moving?
well, I got like some
That's
assignments
what we
due
have to
at
figure
2
out, and I
o'clock.
don't know how
So,
to
you
do
know.
that. But
Bruh,
I'm
I don't know how to
guessing.
do that, but I'm guessing that the 60 is moving down because it's
Again,
more sloped and has
Uh,
bigger mass.
yes, that is 100%
More
correct.
slope.
She's right. More
More
sloped.
slope.
She said sloped, and that's a correct term.
I just heard
slop.
slope. I was like, okay.
Yeah, no, it's more sloped and it has more mass. So yes, the boxes will be trying to move to the left.
Okay.
So, like I said, there's a lot of friction going on here, so I'm going to probably assume on the outset it's probably not going to move. But yes,
So would the friction for the 35 kilograms be to the left as well? No, to the right? I'm
uh,
confused.
yeah, so the
It
friction
would
on the
be
60 will be up and to the right.
Okay.
And that's
Are you
2.
drawing it?
Yep.
Mr. Donald, do you have a link to like a scientific calculator?
I sent out a link to the graphing calculator.
Oh, is it in general?
I sent it on remind. Yeah. It's
Oh yeah,
TI.
which one are we using? Sorry, which one are we using for like the test we're taking?
Well, you'll be using scientific. I don't think a graphing calculator does much of anything for you that you can't use on a scientific. But you can't, even if you use the graphing calculator, since we're doing that, it's not a big deal. But you can't use any of the.
Extra things.
Yeah, you can't use any of the graphing calculator capabilities.
Icky. Also,
Mr. Alone,
on your
Yes.
if I'm trying to find the normal force with 3 blocks, but do I only use 3, or what do I do?
So say that one more time because you're.
reply.
I'm trying to find the normal force, so I can find friction, static friction.
Yeah. You use each of the individual boxes normal forces.
Okay.
So what you'll see as it pops up on the
Then I will
stream.
just add them all together.
Well, you won't add them all together, no. You'll have to make sure they go into the equation properly when we put them all together. So that was FN3.
Alright, I'll see what
This
I can
is FT2.
Does anyone have the link to
I can send it back out for you.
okay,
do. Into what?
to
The calculator. Okay, so free body diagrams are on the board for you. Again, this one is a little bit more complicated because the amount of included frictions. So again,
Wait.
the boxes would be moving leftwards, whatever you want to consider left. So box 1 would be going down the plane, the box 2 would be going left, box 3 would be going up the plane. So that tells you which way friction would be going on all of them.
Okay, but why is the normal force on the 35
Oh,
kilograms going to the left and up?
it's not. I wasn't paying attention. That's when I got distracted.
wait, so you have
Thank
Oh,
you. Should
okay,
be going up. Thank you for that.
okay.
but you have a force of tension on like you don't have it numbered on the first one.
I meant to put a 1 there. Thank you for catching that.
Oh, I thought you already put one. Oops.
I thought I put a 1 there. I
Each
guess
block has
missed
its
it.
own
Mm,
frictional force.
Yes, the
okay.
frictional forces will also be different because they have different masses. If they were the same mass, then you could just say force of friction. It'd all be the same force of friction. But because they are all of different masses, then they have different frictional forces.
Oh, they all have different ones too.
Oh, crap.
Yeah.
Okay. Oh my god, this problem. Why did I tell you to do it?
I don't know.
I needed help on it, obviously, but I just
Well, this is
don't
the
want to
hardest
do
part.
it
Once you
now.
get this done, the rest of it's easy because it's just summing up your forces.
Okay.
So at that point, what do we do after we do our free body diagram? Because I assume we're trying to find acceleration. I mean,
Do you draw the flat
Some
thingy?
of the forces.
well, we have to put it flat before we can do some of the forces.
Oh, we have to put it all together.
So we
Okay.
have our 60 kilogram connected to our 35 kilogram connected to our 45. So again, we're not going to include our internal forces, so the tension forces are going to be internal between the two boxes, so we get to avoid those. So on box 1, what is causing me to move?
Is it
Box one.
gravity?
Gravity,
Gravitation.
and also, while it's not causing me to move, what is not an internal force?
For friction. So
Friction.
FG.
Right, so we have to the left we'll have Fg1x, but to the right we'll have force of friction 1. Then what's causing box 2, the middle box, to move?
The tension, right?
No. Remember, tensions are internal forces. They get canceled out.
Oh,
Does normal force or gravity, does either of those cause the box 2 in the middle to move?
In the middle,
no.
no.
How long's much more class?
About 5 minutes.
Okay, because Terminex is out there.
Okay.
And he's going to need to talk to you because of those green things they don't use anymore. I guess we're have to pay for new ones. I don't know.
Okay. Thank you.
Okay,
It's not Mr. Oh, Mr.
Tell
Mr.
your father we said hi.
I will. All right. So, what's not an internal force on box 2?
Wait, what did you write down on the left side of the first box?
Fg1x.
FG1.
Yeah, because it's the
Wait, I
X
have a
component
question.
causing it to move, not the full gravity, because it's on an inclined plane.
Wait, so where does the FG1X come from?
The component of the gravity down the plane. Remember, on an
What?
inclined plane, gravity is broken into two components: down the plane and into the plane.
Oh, okay, and I see.
Only the one going down the plane causes it to move. Hold on, Ken, I got you. But only the FG1X
Oh.
down the plane causes it to move. The one into the plane does not cause it to move.
Okay.
Okay, Ken, what's your question?
How do you know which one's the X and which one's the Y?
X is up and down the plane, Y is into and out of the plane, by basic definition.
Okay.
So X is motion, Y is not. So this will move up and down. We always just set this to be X because that's how things on a plane move. And then Y is this way. That's just how we do it.
Okay.
So since if we get rid of all the tension forces, would the only force be on the second box friction?
Yes. Because gravity and normal force up and down don't cause it to move. So we have force of friction 2 to the right. And then on box 3, what do we have moving box 3?
We have gravity and friction.
We have FG3 and friction, both to the right.
Would it be FG3X?
Oh, yes, thank you.
And then it was friction F
Mm-hmm.
FF3.
Yep. And
Okay,
now
so
we
finding the friction force is like the part for me I don't understand.
use the equation. We'll talk about that in a second.
Alright.
So then at this point, we put them all together to one
Hunter, it's
box.
FF2, not FF3.
No, I'm
No, I'm
talking
talking
about
about the right box.
Oh yeah, you're like super far behind. We just finished the third box.
Yeah. So then you put them all together. Anything on the right goes to the right. Anything on the left goes to the left. So the only thing on the left in this case is FG1X. And then we'll have a whole bunch of stuff. FF1, FF2, FG3X, and FF3 to the right.
So we would combine all the masses and then write all the forces on the sides.
Yes. And so the mass end up being 105, 110, 140. Yep. Now, like I said, at this point, most likely, the difference between the gravitational forces is going to be beaten by these three frictional forces because there are three friction forces. At that point, most likely, it's not going to move because these three frictional forces are going to be more than enough to keep that in place, most likely.
So what do you have on the right side? It's force of friction 1.
Plus force of friction 2, force of
And-
gravity 3, and force of friction 3.
Okay, it was hard to tell.
Yeah, just everything that's on the right sides.
Okay.
So your homework, figure out the forces of frictions. Remember, think about static versus kinetic. I'm giving you the hint, most likely it's going to be static. Those three forces of frictions are going to probably be more than enough to overcome what the force of gravity 1, the difference between these forces of gravity is on the 60 and the 45. Most likely the friction will be more than enough to overcome that.
Hey, so what was the formula for finding?
So friction is, there's three formulas that you have to understand. Ones that I put up earlier. So you have your force of friction max, which is equal to mu s Fn. You have your force of friction static, which is less than or equal to mu s Fn. And you have your force of friction kinetic, which is equal to mu k Fn. So you use these ideas combined together. Typically, the top one and the bottom one are the ones we use to calculate things, but we have to understand that the static friction can be anywhere in between 0 and that maximum value.
Okay.
So which one was? Hold on, I'm writing these down now. So it's force of friction max. Is that what is that? Is that just all the friction combined?
No, that's the maximum amount friction can be.
You just put it on the
Oh,
computer
and you
screen.
figured
Hunter.
that out with.
That formula, mu s times Fn. And if you beat the force of friction max, that's static friction, then you switch over to kinetic friction. So try to figure out if the
So
box
what
is
you wanna
moving for
do
homework,
is
by the
put
way.
in, like, the top formula down.
Well, you don't really use the middle formula. You just have to have the idea that the force of static friction is not guaranteed to be a specific value. It can change depending on the situation. So for instance, if the maximum force of friction is 100 newtons, but I'm only pushing with 80, well, friction can't be 100 at that point, because 100 would be bigger than my 80, the object would have an unbalanced forces. So you have to have that idea in your head there. That's what that's for. For calculation purposes, you use the top one and the bottom one.
Okay, so the top one is the static formula?
Mm-mm. It's the maximum amount of friction. If you beat that friction, it's the maximum amount of static friction you can have. If you beat that, you switch over to kinetic and you have that kinetic value. Again, think of it this way. You have a really heavy bookshelf. If you push on it with 100 newtons and it doesn't move, then friction is 100 because it's got to counteract you. If you push with 150 and it doesn't move, friction is only 150. But it can be different values. See how it could have been 100 depending on how hard you're pushing, or it could be 150 depending on how hard you're pushing. Now, eventually, you push hard enough, let's say at 200, you beat the friction. Well, I'm assuming you've moved something heavy before. As soon as it starts moving, what happens?
It's heavy.
But what happens as soon as it starts moving?
It starts sliding.
But what happens?
The force I'm applying to it is greater than the friction.
But what happens to it? Like, think about what happens when you start pushing something heavy. As soon as it starts moving, what do you feel?
Tired.
Jesus Christ. It becomes easier to move.
Okay, I honestly don't know what you want from me.
It becomes easier. Like, you don't have to push as hard to keep it moving.
Oh, yeah.
You've never went and pushed something heavy, like had to move a bookshelf or a couch or anything?
Not recently.
Okay, well, go try to move something heavy. It becomes hard to push, and then after it starts moving, it becomes easier to push.
Can I leave now?
Yes, so try to figure out your forces or frictions and if it's moving or not for Monday.